Hello viewers, welcome to the channel Amazing Civil Engineering Studies. In today's video we are going to discuss about types of cracks in concrete. During construction or even after completion, various types of cracks in concrete may appear on the building due to a number of factors. Cracks in concrete usually develop cracks whenever the stress is more than the strength. Stress is normally caused by external loads and forces. In reinforced concrete, cracks may occur due to the inadequate size of their section or reinforcing steel, and corrosion in reinforcement. Cracking of in fresh or plastic concrete. Plastic shrinkage cracks. Plastic shrinkage cracking occurs when subjected to a very rapid loss of moisture caused by a combination of factors which include air and concrete temperatures, relative humidity, and wind velocity at the surface of the concrete. These factors can combine to cause high rates of surface evaporation in either hot or cold weather. When moisture evaporates from the surface of freshly placed concrete faster than it is replaced by bleed water, the surface concrete shrinks. Since plastic shrinkage cracking is due to a differential volume change in the plastic concrete, successful control measures require a reduction in the relative volume change between the surface and other portions of the concrete. These measures include the use of fog nozzles to saturate the air above the surface and the use of plastic sheeting to cover the surface between finishing operations. Settlement cracks in concrete. After initial placement, vibration, and finishing, concrete has a tendency to continue to consolidate. During this period, the plastic concrete may be locally restrained by reinforcing steel, a prior concrete placement, or formwork. This local restraint may result in voids and or cracks adjacent to the restraining element. When associated with reinforcing steel, settlement cracking increases with increasing bar size, increasing slump, and decreasing cover. The use of the lowest possible slump, and an increase in concrete cover will reduce settlement cracking. Cracks in hardened concrete. Drying shrinkage cracks. Common cause of cracking in concrete is restrained drying shrinkage. Drying shrinkage is caused by the loss of moisture from the cement paste constituent, which can shrink by as much as 1%. Fortunately, aggregate provides internal restraint that reduces the magnitude of this volume change to about 0.06%. On wetting, concrete tends to expand. These moisture-induced volume changes are a characteristic of concrete. If the shrinkage of concrete could take place without restraint, the concrete would not crack. The higher the water content, the greater the amount of drying shrinkage. Drying shrinkage can be reduced by increasing the amount of aggregate and reducing the water content. Cracks due to thermal stresses. Temperature differences within a concrete structure may be caused by portions of the structure losing heat of hydration at different rates or by the weather conditions cooling or heating one portion of the structure to a different degree or at a different rate than another portion of the structure. These temperature differences result in differential volume changes. When the tensile stresses due to the differential volume changes exceed the tensile stress capacity, concrete will crack. Cracking in mass concrete can result from a greater temperature on the interior than on the exterior. Procedures to help reduce thermally induced cracking include reducing the maximum internal temperature, delaying the onset of cooling, controlling the rate at which the concrete cools, and increasing the tensile strength of the concrete. Cracks due to chemical reaction. Deleterious chemical reactions may cause cracking of concrete. These reactions may be due to materials used to make the concrete or materials that come into contact with the concrete after it has hardened. Some general concepts for reducing adverse chemical reactions are presented here, but only pretesting of the mixture or extended field experience will determine the effectiveness of a specific measure. Concrete may crack with time as the result of slowly developing expansive reactions between aggregate containing active silica and alkalies derived from cement hydration, admixtures, or external sources. The alkali-silica reaction results in the formation of a swelling gel, which tends to draw water from other portions of the concrete. This causes local expansion and accompanying tensile stresses, and may eventually result in the complete deterioration of the structure. Weathering cracks. The weathering processes that can cause cracking include freezing and thawing, wetting, drying, heating and cooling. Cracking of concrete due to natural weathering is usually conspicuous, and it may give the impression that the concrete is on the verge of disintegration, even though the deterioration may not have progressed much below the surface. Damage from freezing and thawing is the most common weather-related physical deterioration. Concrete is best protected against freezing and thawing through the use of the lowest practical water-cement ratio and total water content, durable aggregate and adequate air entrainment. Thanks for watching.
For now, please subscribe, like, share and do not forget to press bell icon.